Howdy, my name is Carlos Daniel, and today I will be walking you guys through a problem set on kinetics and equilibrium, specifically on photochemical smog. In this video, we will be solving a series of problems, and they're all related to chemical reactions, like obviously involved in the fog formation. Let's get started. All right, so number one is asking us to get the overall reaction. So we're given four sets of reactions, and how we determine the overall reaction is just by adding all of these, and how we do that is just by removing the intermediates and the catalyst. So right now we see that we have NO as an intermediate, so we're going to remove it. And then after that, we would have oxygen as another, not oxygen, O3 as another intermediate. So we would just have to remove that too. So then our overall reaction would be N2 plus O2 gives us NO2 with the subscripts of 2. So moving on to question 2, it's asking us to identify the intermediates and the catalyst, and this is easy. We got that in question 1, and we didn't get any catalyst, so we only got intermediates, and that would be NO and O3. Yes, so then on number 3, it's just asking us what the enthalpy change is. So this one, to get this, it's fairly easy. It's just getting all of the enthalpy changes for all four sets of equations that we got, and we just added them together. And so we would just add that together, and then we would get the final number, which is negative 240.9 kilojoules. So moving on to problem number 4, it's asking us to get EA2, and we would have to assume it's the largest, assuming that it would correspond to the slowest step because it needs the largest amount of energy. And that one would be the second step, which is 2NO plus O2 gives us 2NO2. And moving on to 5, it's which step is the rate determining step, and we know that is step 2 because it's the slowest. So then problem 6 is just asking us to determine the rate of disappearance of NO2 and O2. So we know the ratio. So our given is negative 4 moles per second, and we know the ratio of nitrogen to NO2 to O2 is 2 to 1. So we just multiply that by 1/2, and then we would get the rate of disappearance for O2, and that would be negative 2 moles per second. And we know that the ratio for NO and NO2 is 1 to 1, so we know that is 4, negative 4 moles per second, and that would be the answer for both of those. So then problem 7 asks us to determine the rate law for step 4 using the simple rate law method. So this one's super simple. Given NO plus O3 equals to O2 plus NO2, we would just get the rate, and that would be K times NO times O3. All right, so number 8, I think this might be the hardest one, honestly. So we'll just summarize it. Number 8 is asking us, when the fire has been on for an extended period, the concentration of NO is excess, making the rate loss of step 2 a pseudo order that is solely based on the concentration of O2. For example, rate equals K times NO times O2. Rate equals K times O2 now. So yes, which is the half-life for the pseudo order? So given that NO is in excess, the reaction would follow pseudo first order kinetics with respects of O2, and and its half life is given by T 1 over 2 would equal 0.693 over K. All right, so using our chemistry knowledge, how do you block this photochemical smog reaction cycle? Um, and this is problem 9, by the way. Sorry. Um, so the way we're gonna do this is it's hinting at us to use collision theory and Le Chatelier's principle. So using Le Chatelier's principle, we would just increase the concentration of the products so it can shift the equilibrium away from the smog formation. Because as we know, Le Chatelier's principle is whenever a chemical system is in stress, it'll try and go back into equilibrium. So to block the reaction cycle, we would have to reduce the reactant concentration as well as using the catalyst or increase the product concentration. And yeah, thank you so much for watching. Um, thank you. Here you go.